quadratic inequalities in one variable. So the ones we were looking at before, we looked at linear and quadratic inequalities in two variables when you solve with a graph. Then we looked at linear inequalities in one variable, now quadratic inequalities in one variable. So it's not that different from what we were just doing. Same as before, solve it as if that was an equal sign. So we're going to solve x squared equals negative 3x minus 2. And how would you solve that? We're not going to isolate the x in this one because there's x squared and an x. So it's quadratic. We solve by factoring probably. So let's move everything to one side. X squared plus 3x plus 2 is less than 0. So just adding 3x and adding 2. And then factor that. X plus 1, x plus 2. So our critical values or our boundary values are those values of x that would make those equal to 0. Critical values are x equals negative 1 and x equals negative 2. What that means is our solution set is going to revolve somehow around those values. And really it's probably going to be either the in between those two values or on the outsides of those values. If we think of it on a number line, we'll do 1, 0. Oops. Do you see what I did? Yeah. Put a 0 up there. We'll call that 1, 0, negative 1, negative 2, negative 3. So the critical values are here at negative 2. Whoa. I'm like negative 2 and negative 1. Our solution set is either going to be out here, in between here, or out there. Or probably, most likely it would be in between or on the two outside parts. So we need to figure out where it goes. And the way I do that is to test values in each region. So we have 3 regions here. We have this region that's less than negative 2. We have the one that's between negative 1 and negative 2. And this one that's greater than negative 1. So we're going to test all 3 regions. Test. We need to pick a point in each region. So I'm going to call this region 1, 2, and 3. So testing in region 1, I'm going to pick a value that's in that region. Can't write today. What value do you want to pick? We're not going to choose the critical value, so negative 3 will work. Yep. Let's pick negative 3, and I'm going to fill it into the original inequality. So I'll go negative 3 squared is less than negative 3 times negative 3 minus 2. I get 9 on this side, and on the other side, 7. We have to decide is that true or false. False. Because it's false, it means the solution set is not in region 1. So then we'll test region 2. What number do you want to pick in region 2? You can't choose negative 2 because it's a critical value.
1.5?
Yeah, it's going to have to be a decimal number like negative 1.5. So let's do negative 1.5. Negative 1.5 squared. 2.25. And then we'll multiply negative 3 times negative 1.5 and subtract 2. That gives us 2.5. Is 2.25 less than 2.5? Yes, so that one's true, which means in between here is our solution set. I'm going to test the third region quickly just to be sure. Usually it's going to be either the two outside pieces or the inside piece, but just to be, there is the odd time when something weird happens there. So I'm going to test 0, and I get 0 is less than -2, and that's false. So it is only in between those two values. I also need to be able to write a statement. So your statements previously looked like something like x is greater than -2, or x is less than or equal to -2. What's your statement going to look like for this one? -2 is less than x is less than -1. That's the answer. So the answer shown on a number line, that's the answer as a statement. When it's between two values, lower limit, less than, variable, less than, upper limit is the way that it goes. So this one, same thing, we're just going to solve. 2x squared is greater than or equal to 7x plus 4. 2x squared minus 7x minus 4 is greater than or equal to 0. This one, the last one was less than, was it? Or greater than, didn't have the equal to. So remember what that's going to look like on the graph. That's different. The first one, if we go back and look at it, has an open circle, two open circles on the graph. This one is going to have closed circles. We can factor this. I think that's right. 2x squared, that's minus e plus 1. Yep. So then we find our critical values again. Critical values are x equals -1/2 and x equals 4. Once we have them, we're going to put them on a number line. And we're going to draw closed dots this time at our critical values. Why are they closed? Because it equals. It's greater than or equal to, not just greater than. So we'll draw one at 4, a closed circle. Except I can't seem to fill it in. There we go. And one at -1/2. Where's -1/2? In between 0 and -1. So there. So now we have to figure out our solutions in region 1, 2, or 3. Chances are they're either in 2 or they're in 1 or 3, like both of those sections. But let's test some values. We'll test in region 1. Do you want to test -1? So I fill -1 in, and notice I'm filling in for all the x's, right? So here I get, that's just 2, and that's -3. 2 is greater than or equal to -3. True or false? True. So then in here I have solutions. I'm still going to test all 3 regions. So I'm testing 0 because it's in that region 2. This is 0 is greater than or equal to 4. Is that true? No. And then we'll test region 3, which is probably going to be true. We'll use 5. 39. 25 is greater than or equal to 39. True?
I don't think 15 is 50.
Oh, there's two of them. So now it's true. 2 times 25. 50. True or false? True. So there's the other region. So on the graph, that's what it looks like. How do I write a statement about that?